Welcome to Glad Labs podcast. Today's episode, the steam engine of the 21st century, why custom water cooling might be your best investment. The modern data center is evolving. It's moving away from the traditional image of a dusty server room and increasingly resembling something closer to a biohazard zone. Not because of radiation, but due to the immense heat generated by GPUs processing billions of parameters every second. As the industry shifts toward what are being called AI factories, facilities designed specifically to generate intelligence rather than just process data, the challenge of cooling has become the primary operational constraint. For both individual developers running local models and large enterprises scaling inference, the question isn't if hardware needs cooling, but how. While large-scale solutions like rear door heat exchangers are becoming common in massive data centers, many are turning to custom water cooling systems. But is this a sound engineering decision, or simply a pursuit for those enthusiastic about thermal performance? To understand the answer, it's necessary to move beyond the aesthetics of RGB lighting and focus on the thermodynamics of artificial intelligence. Building an AI model is essentially building a massive mathematical engine. The heat generated isn't just an annoyance. It's a direct cost to computational efficiency. When a GPU overheats, it doesn't just slow down, it begins to throttle. Thermal throttling silently kills inference speed and training stability. Recent industry analysis confirms that AI compute is creating an urgent need for specialized thermal solutions. Organizations attempting to solve this heat problem are discovering that traditional air cooling is no longer sufficient for the power densities required by modern accelerators. Consider the approach taken by major hardware providers. Companies like Dell have introduced solutions like the PowerCool eRDHx, an enclosed rear door heat exchanger. This technology eliminates the need for chilled water loops within the data center itself by moving the heat exchange process directly to the rack door. The principle is simple. Efficiently removing heat from the room reduces the massive energy costs associated with climate control. However, this technology is expensive and complex to implement at scale. For those building their own infrastructure, the question remains, can a custom water cooling loop achieve similar results at a lower cost? The physics certainly suggest it can. Water has a specific heat capacity roughly 4 times that of air. This means it can absorb significantly more thermal energy without a substantial increase in temperature. In the context of an AI workload, where a GPU might sustain 100% load for hours, this ability to absorb heat is the difference between a stable 90 teraflops of performance and a system that throttles down to 60 teraflops to protect itself. When evaluating the economics of cooling, it's helpful to consider the total cost of ownership, or TCO. Industry benchmarks for building and deploying AI chatbots suggest that costs can be substantial. Estimates place the monthly subscription cost for high-end AI capabilities at over $5,000, with build costs potentially reaching hundreds of thousands of dollars for advanced deployments. In this environment, protecting your hardware is a financial imperative. A GPU that fails after only 6 months due to thermal stress represents a catastrophic loss. A standard air cooler might handle the heat for a few hours of gaming, but it's rarely designed for the 24/7 sustained load of an AI inference server or a continuous training job. Custom water cooling offers a different economic argument. While the initial setup cost for a high-end loop, including pumps, reservoirs, tubing, fittings, and specialized blocks, can be significant, the operational payoff lies in longevity and stability. Many organizations have found that robust thermal management extends the hardware life cycle. By keeping components within a narrow, optimal temperature range, you prevent the thermal fatigue that leads to component failure. Furthermore, consistent temperatures mean consistent performance. In an inference scenario, where you might be serving thousands of requests per second, even a 5% performance drop due to heat translates to a direct revenue loss. This leads to the concept of the invisible tax. Just as Docker introduced an infrastructure tax that developers must manage, thermal management introduces a tax on power consumption. A cooler system doesn't just run cooler. it runs more efficiently. The laws of thermodynamics dictate that as a component heats up, its efficiency decreases. By keeping it cool, you get more work out of every watt of electricity. The narrative shifts when we consider the individual developer's lab versus the enterprise data center. For a solo developer or small team, the economics of enterprise cooling solutions like rear door heat exchangers are completely unrealistic. Yet, the need for power remains the same. This has led to a surge in the DIY AI infrastructure movement. The solo developer's secret weapon is often not a cloud subscription, but a powerful local machine. However, a single high-end GPU, like an RTX 4090 or 5090 class card, in a standard PC chassis presents a significant thermal challenge. This is where custom water cooling moves beyond being a luxury and becomes a necessity for serious work. Air coolers for these cards are often massive, bulky, and noisy. A custom loop allows for a more compact thermal solution that can be integrated into the case design, reducing noise pollution, a critical factor when running a model 24/7 in a living space. However, the decision isn't always simple. You must weigh the complexity of the loop against the intensity of the workload. For a developer running a local RAG, retrieval augmented generation, pipeline occasionally, the risk of a leak might outweigh the benefits. But for a developer running a continuous training job or a high-volume inference API, the stability offered by a closed-loop system is invaluable. It's worth acknowledging the complexity involved. Unlike a standard air cooler that's essentially plug and forget, a custom loop requires maintenance. You're dealing with pumps, fluids, and potential leak points. This adds a layer of complexity to your infrastructure stack, similar to managing a database connection pool or a background job queue. If you're already struggling with the basics of Docker or deployment pipelines, a custom cooling system might be too much to handle. There are also intangible benefits to custom water cooling that are harder to quantify, but no less real. The first is noise. In an AI factory, the sound of cooling fans is simply background hum. For an individual, that level of noise is unbearable. Custom loops allow for high flow rates with low RPM pumps, drastically reducing acoustic output. The second is the thermal envelope. When you water cool a system, you effectively remove the thermal bottleneck. This allows you to push the GPU to its maximum potential without fear of thermal throttling. In the context of fine-tuning models, this means you can run longer training epochs without the GPU dropping in performance. This aligns with the challenges of fine-tuning. The math is complex enough without adding thermal instability to the mix. Furthermore, custom loops offer aesthetic and monitoring benefits. Many loop builders integrate temperature sensors directly into their tubing, allowing for real-time visualization of thermal performance. This data is crucial for optimization. You can see exactly how your thermal paste performs under load or how your radiator capacity handles a specific workload. Ultimately, the return on investment for custom water cooling is realized when you view your hardware not as a consumable, but as an asset. In an era where AI compute costs are high, ensuring that your asset performs at peak efficiency for as long as possible is a sound business strategy. Deciding to implement custom water cooling for AI workloads is a decision that sits at the intersection of engineering capability and financial prudence. It is not a one-size-fits-all solution. If you're building a massive AI factory in a commercial setting, the industry standard is moving toward integrated rack solutions. These systems are designed for scale, redundancy, and professional maintenance. However, for the individual builder or the small-scale operator, custom water cooling offers a pathway to a stable, high-performance environment without the enterprise price tag. It requires a commitment to learning, but the payoff is a system that runs cooler, quieter, and more reliably. Before you dive into the world of pumps and fittings, audit your thermal situation. Check your power draw. Look at your ambient temperatures. If you find that your hardware is constantly fighting the heat, a custom loop might not just be a cool upgrade. It might be the upgrade that keeps your AI project alive. Thanks for listening to GladLabs Podcast. Visit gladlabs.io for more episodes articles, and insights. See you next time.